This microcredential is about forestry measurement and processing and has three targeted skills. This targeted skill is about tree measurements. About 15 to 20% of tree species have commercial value, so it is possible to harvest some trees to thin out a forest. Knowing the size of the trees in a forest is the first step to understanding the value of the trees. Tree circumference and diameter are starting points for taking tree measurements. They are taken at breast height, or 4.5 feet up the tree trunk from the ground. This is a standard used in forestry. Circumference is a good index of tree performance and is the basis for estimating tree volume. It can be measured with a simple tape measure. Diameter at breast height, or DBH, is based on trunk circumference 4.5 feet from the ground. An instrument called a tree caliper measures the diameter of a tree trunk. If you have a tree circumference at breast height and need the diameter, use this formula to calculate it. Diameter is equal to circumference divided by pi. Pi has a value of 3.14. For example, if a tree's circumference is 40 inches, divide 40 by 3.14. The diameter at breast height, or DBH, is 12.7 inches. For medium-sized trees, a common tool for measuring diameter is the Biltmore stick, which is similar to a yardstick. Hold the stick against the tree at breast height, 4.5 feet from the ground, and at arm length, about 25 inches. Keeping the eyes level with the stick, align the left scale to read 0 at the left edge of the trunk. Keep your head straight and look at the measure on the right side. This is the diameter at breast height. The scale on the Biltmore stick indicates diameter without bark. Basal area, BA, indicates the area occupied by trees. It can be measured for individual trees, but is most useful as a measure of tree density averaged over a forested area and relates to the volume of a stand of trees. Calculations of basal area can indicate whether a stand of trees needs to be thinned, as well as help to estimate the amount of wood, carbon, and biomass contained in the stand. Biomass is a renewable energy that comes from organic material, like plants, for example. The calculation for basal area is based on the diameter at breast height, dBH, and uses the Forester's constant of 0.005454 to convert inches into square feet. The formula is this: basal area per tree in square feet equals 0.005454 times the dBH squared. The tree in the earlier example has a dBH of 12.7 inches. Its basal area would be 0.005454 times 12.7 squared, or 0.005454 times 161.29, which equals 0.8797 square feet. To estimate the basal area for a larger stand of trees, take data from 10 randomly selected points, representing 5 to 10% of a tree stand. Stand in the middle of a point and measure the trees within a 37-foot radius while rotating in a circle. The area of a circle with a 37-foot radius is about 1/10 of an acre, so add the basal area of the trees and multiply by 10 to get an estimate of the square foot per acre. Repeat the process for each selected point, then average the data from all points to calculate the square feet per acre. The optimal density of trees per acre varies according to the type of forest and tree. For example, if you sample 5 points in the tree stand and average the basal area for it, it looks like this. Therefore, the average basal area is 400 divided by 5, which equals 80 square feet per acre. The optimal range for the basal area is from 60 to 70 square feet per acre. Values lower than this do not favor timber growth, while values greater than 100 indicate crowding and slow growth of trees due to competition for sunlight and nutrients. Tree height is used to estimate the amount of lumber a trunk contains. One way to get this measurement is to climb the tree and drop a measuring tape, but this is not always possible. There are easier ways to measure tree height based upon geometry. Total tree height is the entire height of a tree from the stump, or a foot above ground, to the top or tip. The tree height contributes to the estimation of its volume and weight. A merit hypsometer can be used to estimate tree height. This scale is often found on the Biltmore stick. To use the merit hypsometer, stand 66 feet from the base of the tree. Hold the scale at arm's length, or 25 inches from your eye. Line up the bottom of the stick to the bottom of the tree. Observe the treetop on the scale. The scale of whole numbers represents 16-foot increments, which is the size of a standard log. If the treetop is at 4 on the merit hypsometer scale, then there are 4 16-foot logs. The tree height is 4 times 16, which equals 64 feet. Understanding these measurements and how to take them is important in managing the forest. Several basic measures, such as tree height, diameter, and basal area, provide important information about the health of the tree stand.